So we can have the equations in the polar system. And since we don't have too much knowledge about the polar system, so we like to convert those equations in the polar system to the equations in the rectangular coordinate systems. So, and also sometimes we need to convert the equations in the rectangular system to the equations in the polar system, because for some geometric objects, it's very simple to express them in the equations in the polar system. So let's first see how we do this conversion. Let's put the polar system and the rectangular system together. So this is the rectangular system, and I use the red for the polar system. Okay. So now, suppose I have one point, and its polar coordinates is the r and theta, and the rectangular coordinates is the x and y. Let me call this point P. So now we can form a right rectangle, a right triangle in such a way. So now we know this guy, the length of this neck is the x, right? And the length of this neck is y. So right now, I first assume this point is in the quadrant 1. Then, from the trigonometric ratio theorem, we immediately get x over r is equal to the cosine theta, right? And then y over r is equal to sine theta. So now, if I know the polar coordinates of this point, I want to find the rectangular coordinates of this point, then I can use such a formula. That is x equal to, okay, I multiply both sides of this equation by r, then I get x equal to r times cosine theta. And then similarly, I get y equal to r times sine theta by multiplying both sides by r. So this is how we convert from the polar system to the rectangular system. Now, suppose I know the rectangular coordinates of this point. How do I find the polar coordinates of this point? So this time, we know in this red rectangle, this guy is r, right? So by the Pythagorean theorem, we have the x squared plus y squared equal to r squared. And then we just take the positive solution. So we have the r equal to the square root of x squared plus y squared. Okay. And then we need to find the angle theta. So now, tangent theta is equal to y over x. Right? So right now, we do this conversion just for the case when the point is in the quadrant 1. But actually, all these formulas hold for the points in the any quadrant. So not only in the quadrant 1. So now, let's try to solve this equation for theta. If the point P is in the quadrant 1 or quadrant 4, then we may have such solution, since we know the inverse tangent of y over x is between the negative half pi and half pi, right? So suppose here x is not equal to 0, and we'll deal with this special case later. So now, if the point P is in the quadrant 1 or quadrant 4, then we may just use this inverse tangent of x of the y over x as the solution. So theta here is equal to tangent inverse of y over x if this point P is in the quadrant 1 or quadrant 4. Okay, because if you have the acute angle, then this point is in the quadrant 1. If you have this negative acute angle, then this point is in the quadrant 4. But if the point is in the quadrant 2 or quadrant 3, then since we just take the positive square root for the value of this r, so we have to add pi to this inverse tangent of the y over x. Let's move to the next page. So now the same case, theta is equal to pi plus tangent inverse of y over x if this P is in the quadrant 2 or quadrant 3. Okay. So actually, you go back to this graph. Say if you have the point here, right? And then how do you find the polar coordinates? So first, you know one angle, which is the tangent inverse of the y over x, but that is this negative angle, right? And the r is positive. So, but the point is here in the quadrant 2. So, to get angle of this point, you need to add a pi to this negative angle to arrive here. So, to find this angle, say, let me call this theta 0. Then this guy should be the pi plus theta 0. Okay, so this is how we find the angle for the polar coordinates of the points in the quadrant 2 or in the quadrant 3. So remember to add this pi to this tangent inverse of the y over x. Now, two special cases. X equals 0 and the y is positive. So if the x is equal to 0 and the y is positive, we know it's on the positive y-axis, right? So it's here. And then its angle should be equal to 90 degrees, or say half pi, right? So in this case, theta just equal to half pi. And if the x equals 0 and the y is negative, we know the point is in the negative y-axis. So in this case, the angle is equal to 3 pi over 2. So now we take theta equal to 3 pi over 2. And then in this way, we can convert from the rectangular coordinates to the polar coordinates. Any question? Now let's look at the page 638, problem 22. We convert this polar coordinates to the rectangular coordinates. So the polar coordinates is -5 and 0 degrees.